Welcome to webinar 2, focusing on operations, maintenance, and repair. Last week we dealt with surveillance and inspection, and same time, same place, next Saturday will be our final webinar dealing with emergency planning and response. So my name is Dwayne Tannant, and with me is...
I'm Hahn. I'm with Interior Dams.
And I'm with the University of British Columbia, so welcome.
Welcome.
Before we get started, just an acknowledgement of who provided the funding to make this webinar series possible. So it came from the Canadian Agriculture Partnership, which is a federal-provincial-territorial initiative. And of course, the province of BC and the dam safety section is very supportive of trying to have these continuing education webinars and seminars and workshops. And of course, this year with COVID being present, we've moved everything online. And I think that's made it a bit easier for people to attend, at least we hope it has. And so with that acknowledgement for that funding, we're going to move on. Webinar 2. So the topics for today. We will talk about operations of small earth dams, which are typical for agricultural uses. We'll look at routine operations and operations under extreme conditions, and tie a little bit of the operations into monitoring and potential instrumentation that you may have on your dam. We'll talk a little bit about maintenance, and some of the things that are routine maintenance and things that I'm sure some of you may be struggling with. So we'll give some examples of what well-maintained dams look like and those that are not well-maintained. A little bit on equipment testing and repairs, and just a touch up at the very end of this webinar on the importance of keeping records of your activities in terms of maintenance and repairs, as well as operations. So those are today's topics.
And Dwayne,
this webinar is being recorded. It should be over in 19 minutes or less. We hope to have some time near the end to open up for kind of discussions and answer some of the questions that may have come through chat. You do have the chat button. If you haven't found it yet, it's usually at the very bottom of your screen, sometimes at the very top. You could open up another window, which would be the chat window, and feel free to send a message to all of us, or a private message. If it's a private message, it should go to Aaron, because he's kind of moderating the chat today. At the very end of this webinar, for those that are interested, Aaron will provide a link to obtain a certificate of attendance. So that'll be provided at the very end of this webinar. Okay, I think that's it for housekeeping.
Yeah, that's good.
Did I miss anything, Aaron? Okay, good.
No, I think that's it.
So getting into it, operations, maintenance, and repairs. It's a part of the regulatory requirements for a dam owner. And so we have this bit of text extracted out from the regulations. Last week, we focused on the inspection part of this little bit of text. Today, we look at the maintenance and repair aspects and link to operations of a dam. So this is where we live, and it's a requirement. It's a responsibility for a dam owner to maintain and repair their dam, keep it in a good working condition, so that there's no harm going to occur to the public or the environment or properties downstream. And that includes preventing unauthorized operation of your dam. For example, your low-level outlet, you got to make sure somebody else can't come onto your site and open up a gate valve or stop logs and cause some flooding downstream. So those are embedded in the regulatory requirements. And to meet those regulatory requirements, a dam owner is going to have to store the water for the intended purpose. The water license is linked to a specific purpose. And you should know when you need the water. You should know how to operate the dam. And a little bit on today, and certainly on next Saturday, what do you do when you have extreme inflow conditions? a larger than normal snowpack combined with, I don't know, early season extreme precipitation events. So you need to know how to handle those conditions, and they should be embedded in your operations, maintenance, and surveillance manuals. And so these extreme conditions hopefully don't occur very often, but when they do occur, it's important that you know what to do. And that's making sure that you operate your dam in the correct manner, and ensure that things like your gate or outlet valve work, because it may be important to use that to draw water down. Make sure your spillways are adequately sized and not blocked. Making sure that you have physical access to your dam. The roads aren't washed out or you're impeded in terms of your access. And then we'll talk about that today. Vegetation often can inhibit access to the dam, the road access or the physical access onto the embankment itself, and it can prevent convenient inspection of your dam. So vegetation management is a never-ending challenge when you own these dams. Of course, things get old and they wear out. You're going to have to repair things that are broken or need maintenance. And finally, in terms of the regulations, it's kind of very important to keep a written record of what you've done, when you did it, so that there's some evidence that you are operating and maintaining your dam in a manner that you're trying to do the right thing in terms of keeping it safe. So keep those written records and documentation, photographs, etc.
Dwayne,
you're meeting regulatory requirements. Yes, Aaron.
Yeah, one comment I was going to say is, and this sheet here also assumes that inspection we've already covered last week. And so we're also assuming in this workshop that you have some understanding of inspection, because that's really the building blocks of how you know what to do next, certainly in the maintenance and the repair aspects. And so that's not really covered in this list here.
Exactly. I mean, building on last week's webinar, you might have inspected your dam, saw some deficiencies, and we went through quite a few deficiencies and types of deficiencies last week. And now we kind of switch our focus a little bit about what do you do about it? How are you going to maintain that and repair that? So we'll touch on some of that. Of course, in a 90-minute webinar, we can't be covering all possibilities because there's so many things that could go wrong or that could need repair. Your dam and your water license is kind of linked to this phrase, purpose of use. And normally, for most people attending today, the purpose of use is probably to store water for either livestock or irrigation purposes. And so that's the purpose. We're storing water for a specific need, and there's your license would have some quantities tagged to that. What your purpose of use typically is not for is for flood control. And we'll come back to that in this webinar in terms of how you would operate your structure. So your purpose for use is just to hold back some water for the dry time of the year when you need it for livestock or for irrigation of crops. And of course, as climate change unfolds, we're likely to see some increasing extremes, either extremely dry periods of time, which might be motivating people to hold back a bit of water. But then we could also have the opposite, where we have intense convective rainstorms in the summertime or late spring, or higher than normal snowpack in the spring as well. So we have to kind of be balancing both the high inflow runoff events plus those associated with droughts. And so those are a balancing act that you have to engage in when you're managing your reservoir and your dam. And as we move forward with climate change, there's probably this desire to capture and store more winter precipitation. We're just going to need a little bit more water in the late summer. If your dams are subject to Part 3 of the regulation, we talked about the dam classifications and what dams fall under Part 3 of the regulation last week. That's probably going to cover most of the people here today, based on the dam classifications that were reported last week by the dam owners. You need to have a operations, maintenance, and surveillance plan. So we often call that an OM&S manual. It's a written document, and almost all dams should have this document. And the degree of complexity of this document will probably vary depending on the consequence classification of your structure. And so we talked a little bit about the surveillance part of that plan last week. We'll talk a little bit about the operations and maintenance part of it this week. So what would be typically in a OM&S manual or this plan? Of course, some information about your dam, and information about how you access it, maybe alternative access routes, particularly if you have an extreme climatic event and one road gets washed out. Well, do you have a plan B? Is another way to get to your dam to operate it during that extreme precipitation event? And then procedures. There should be a set of procedures about how do you operate your dam under kind of normal routine conditions, but it should also include explicit mention of what do you do when you have extreme conditions. Have those written procedures, there's a thought process, you've gone through that and you've written it down. And of course, maintenance procedures, what are routine things, what are the things that you're going to be expecting to be doing on your dam, and the frequency of those maintenance activities. And then if you do have a little bit of instrumentation, and actually every one of you have instrumentation, which is your eyeballs connected to your brain, you're looking at your dam, you're monitoring it visually, and you may be looking at reservoir levels and seepage, and maybe you have piezometers. And so there should be some written documents about how you monitor the dam, how do you collect the data, how do you present the data, and making sure that you look back over time to see if things have changed over time. You're looking for changes which might be indicating a change in behavior of your dam, which might be indicating the dam's becoming less safe. And of course, there will be inspection and surveillance procedures. We covered that in webinar 1. And then your OM&S manual may refer to a dam emergency plan. So basically, it's procedures of how you are going to respond if there is a emergency. And so that'll be a focus of webinar 3. And all of those things are often in that document if you've got a nice OM&S manual.
Dwayne,
so, yes.
I just added a link to everyone to an example of that OMS plan that you just showed. And also, and I just sent a link to a complete dam safety management system binder, which includes that OMS. So you can get an idea of how all those procedures, you might want to wrap them up in one big binder. And so that last link I just sent you is basically that whole binder, and we used to cover that under some full day workshops. So that may be useful to some.
Okay. And for those that are attending today, if you can find that chat box and open it, you will see what Aaron had mentioned. There will be a link, and all you have to do is click on it, and those files will be automatically brought down to your computer. So just like last week, just to keep things a little bit interactive and for us to understand the audience, we have some polls we would like to run. And so this webinar has got 4 of them. They're very short. You don't have to participate if you don't want. It's anonymous. And I am going to launch the first poll. So you should see something flash up on your computer now. And all you have to do is click your answer. And if I give you guys maybe 10 seconds to answer the 2 questions, first one being, how complete is your OM&S manual? And the second one, have you used it? Have you referred to it at least once in the past year? So we've got a dozen people have responded so far. I'll just kind of watch the rate of response and end the polling as the rate dies down. We're coming up to maybe 50% of the people have decided to answer the question. And I'm able to sort of see live the response rate, but I'll share that with everyone here shortly. I think everybody, it's slowing down, so I'll just end the poll and share the results. So here's the shared results. How complete is your OM&S manual? I do not have one or have lost it. So that's dominating the people that are attending today. And if you are under part 3 of the regulations, you really are supposed to have one of these documents. And so please try to take advantage of the links that Aaron has sent to you. And those that do have it appear to be looking at it or referring to it, once a year. So there's a little bit of feedback, so you can kind of see how you're stacking up versus other dam owners here in the province. I'll end that sharing and pass over the microphone to Aaron.
Yeah, and to comment on that past poll real quickly, gives you a sense too that nobody's perfect. So your regulators really are a great source, like they're a resource for you. And when you call them, you can be transparent about where you're at. This is a work in progress. You can never be safe with a period, right? It's always getting closer and closer to being 100% safe. And there's always room for improvement. And just goes to show you they are aware there's a lot of dam owners that aren't meeting the standard. And so, yeah, they're there to help you. So don't be embarrassed about that. Okay, so routine operations. So I should have control here, right, Dwayne? You might have might just have to give me over control there, and then I'll have control as well.
Right now, Aaron.
Yeah, okay, beautiful. There we go. So operating procedures. So we're going to try to delve right into all the things that we might not typically think about. So you don't know what you don't know, all of us, myself included. So we're constantly, we have new awareness of the different things we should be aware of. So here's some of the things. Typically, a lot of these dams, we might only have one valve on them, right? But there's still a lot of stuff to think about how we operate that one valve. So reservoir storage rules. So we'll talk about rule curves and different things in later slides, but typically we'll have storage volume targets throughout the year. And so we'll operate that valve, we'll open it or close it depending on what we'd like to target. So there's full service level, FSL. We want to consider inflow design flood. I'll just jump back one there, Dwayne. Oops, I gotta click and then grab back. So inflow design flood, we want to be considering that. Seasonal reservoir storage targets, so late in the summer, we want to budget our water. So to do that, there's a couple of things we need to know. Maximum safe discharge rates, right? So let's say we want to draw that thing down quickly for whatever reason to follow our rule curve or our targeted storage water level. We need to know how quickly can we draw that down, or maybe how much can we store? Can we fully close it and store all the water, or do we have environmental flow needs? Do we have to be considering fish? Is this on-stream or off-stream storage? There's a lot of things to consider. One other thing is procedures for closing valves. Many of you, particularly irrigation systems, you may have your sprinkler systems connected directly to the outlet of your dam. So closing that upstream valve may actually cause surge or even vacuum conditions through your low-level outlet. So you really want to think about all the operational constraints that your system may or may not have. So here's going to the rule curve slide. So Dwayne, can you see my mouse moving there? Oh, I'll jump back. Can you see it moving on the screen? Okay, so this is what I'm talking about here. In the spring, or I should say winter, we're talking January here, right about this time, we don't really have a lot of water in there. We might have a lot of snow around our catchments. It really depends where your dam is, but this is pretty typical. And then as spring comes and it melts, it fills the dam. So just looking here, let's pretend this here is all our live storage. So from our valve to where it naturally spills over, this is our live storage. We may have an annual average demand of this amount, And we typically might have a licensed storage amount for a dry year. So we may be licensed for this much water. So typically we have a little bit of buffer balance in there, and also surcharge, right? If we get a big spike inflow, sometimes we have some additional freeboard here. So this is what we're talking about. This is our dam system, however, whatever type of dam you might have. And this is what our rule curve might be, the amount of storage going up on the horizontal axis and the time from January to December in any given year. So we have freshet, where typically our reservoir is filling, and then we have our demand, where it's typically decreasing, and then it starts to come up. So this we call the rule curve, for those who aren't aware. So we're going to want to basically, in different years, if you were to track your reservoir levels, it would go all over here, but on an average, we would want it to look like that generally. And so here you might have, I realize most of you might say, oh, well, we don't need this in our manual, because it's pretty simple. You close it in the wintertime, you open it late in the summer when you need it, and that may be maybe all you need is just two rules of thumb. But I do recommend having that in your operation maintenance surveillance plan, because if you're away and someone's got to open that, or takes over a ranch or whatever it is that the dam's for, then they know how to operate that. So anyway, we're going to be talking about rule curves a little bit, and that's what we're talking about right there.
And that rule curve could be presented graphically like you just had, or it could be in table form.
Yes. Mm-hmm.
There's various ways of documenting that in your OM&S manual.
And it's quite typical, even for municipal level dams, if they're simple dams, to have 2 or 3 sentences there in their operation on how to operate that valve. And they'll just have very simple rules of thumb there, but at least they're written down. So maximum safe discharge rates. We're going to have some examples of this later, but this is it in a nutshell. Maximum flow you can safely release, right? You need to know what that is. So stability of your dam and reservoir slopes could be affected. There are hydraulic design limits, so whether it's the size of an outlet, it could be your channel, it could be a number of things. We're going to go over this a little more in detail. Your low-level outlet, there's a lot of things people don't think about. Oftentimes, depending on the type of flow, I'm not going to get too technical here, but the type of flow that's going through your low-level outlet, you could cause a hydraulic jump, which is basically where it goes supercritical to subcritical. And then you may have kind of this wave of water coming up and down inside of your pipe. And so at certain openings, if it's not a properly vented system, you could have surging and even some negative pressures. So there are some things you might want to be aware of, or at least pay attention to when you plan, when to open, how far to open your gate, even if that's the only thing you have, because you may actually cause cyclical surging, which could really, it could damage your low-level outlet. So anyway, we're going to look at that a little bit more later in this workshop. So when I said things like your reservoir, your upstream slope, how that could cause instability, here's an example. Here in the Okanagan, our dam materials are typically a little more permeable, so we're not as worried about this, but some of the dams certainly, as you go further north in the interior or further north in BC, you get into more clays and things. And generally, if your dam, if you can draw your reservoir down quickly in comparison to how quickly your dam can release that water, allow that water to leave the structure or the soil of the dam, you may actually cause instability. So you may, if you draw it down quickly, you might see even slopes of your reservoir slide in, or maybe it's almost like an approach bay to your spillway, or like an approach channel. You might fail that approach channel, so material could slump into your spillway area. So there's a number of different things, and this is just how it's graphically represented. If you see my mouse here, once you take the water away, you don't have the pressure of the water holding the slope up, and then you have these hydraulic pressures that are, you can see the line where the water is still in this embankment. It wants to slide and slump down. And so here's an example. If it were the upstream of your dam, here's the hydraulic or phreatic surface through your dam. So the level, kind of like the level of groundwater. If you draw this down quickly, this could slump back because you don't have the water pressure holding the dam. So just, it may not be something that you need to worry about with your dam, but it's to demonstrate there could be a lot more things going on, so or that you should be aware of. And so here's a couple examples of some slumping. This is definitely a slope going in. I'm not exactly sure if this was from a rapid drawdown, but certainly some of these are. And so these are the types of things you could get some instability. So maximum discharge rates. So even if you don't have a flood, if you release water more quickly than you could otherwise downstream, you need to be aware of what some of those limits are. So here's an example of a little creek crossing, a little bridge. You definitely wouldn't want to cause something like that just by the operation of your dam. And also this structure probably has quite a bit of capacity, but that may not always be the case. If you have a really large low-level outlet, you could have something like that could actually have less capacity than your upstream valving. So it's just things to be aware of, to look at your design and understand what types of constraints might I have. So and other things too, is it a type of design that could clog the system up? Just a side note, I don't particularly like these designs because if you ever try to inspect them, you're usually knee deep in water. And if you ever want to camera or rehabilitate the low-level outlet, you have poor access. Anyway, that's just a little side note there. But we are talking about repairs and maintenance. So lots of things to be aware of, especially when you're upgrading. So I alluded to this before, the safe discharge rates. So if your low-level outlet is not properly vented, so here's what I'm talking about, different types of flow. If you have just a small opening and high head or a full reservoir with lots of pressure, it will shoot out like a jet. So it'll be a different type of flow than if it's let's say tailwater controlled with low head. It'll flow through quite differently here. And so the demand of air in this pocket will be very different. And if you have something like this where you have a bit of a hydraulic jump, where you have a full pipe, this pocket of air could be surging, and you can cause some problems. So anyway, one thing to be aware of is test your valve system, release it, see how far you can go, and try to listen for that pipe. Is it chugging? Is it doing something? Look at your downstream and find out what your system is capable of doing. Here's an example of this is what happens if you fill a ditch really full. The side banks get saturated, and then you shut the valve quickly, and then what happens is those slopes of your irrigation ditch are still saturated. There's no water pressure behind it, and it slumps in. And so you could have failures like this. Other problems are excessive scour. If it's not properly protected from that erosion or those tractive forces, it can break down over time, and so that's another constraint to your system. All right, so operating under extreme conditions. So I just want to reiterate, or at least make a distinction here. Extreme conditions are not emergencies. We're going to be covering emergencies in our next webinar. So we're talking about under typical design conditions. So our dams are designed for sometimes 1 in 200, 1 in 1,000 years. So we need to be aware of those, and we need to plan ahead. So here's an example. You could jump on the river forecast system. You could learn about, you can be ready for all kinds of events. I'm just going to share a quick link here. If you were to check right now, the interior and places in far north do have quite a bit higher flows. And so we can expect that in the spring. So here's an example. We covered this example in our last webinar, and so we're going to take it a little further. Let's pretend you have a dam. You have an extreme rain on snow event. So here's a clue. It's less than the design event. Reservoir is near maximum. So the surge water is coming up. So everyone feel free to chat. You can chat to myself. What would you do, right? extreme rain on snow event, reservoir is near the maximum. And does anyone, can they think of what they would do? Would you just kind of hang tight? Would you check the river forecast system? So here's a little more information. The downstream Forestry Service road has just failed. Houses below are beginning to get flooded. Let's say you got a downstream neighbor, they're calling you, they think your dam might have breached, you know, they're starting to get a little worried. What do you do as a dam owner? Do we have any comments?
Hopefully your OM&S has some guidance for how to operate that dam under those extreme inflow conditions.
Exactly. And if you have your OMS manual, you know what, you know, how far you can open your valves. You'll have a little more information there. In the interest of time, I'm going to just keep going here. And the important thing is you do not compromise dam safety. So you always want to allow the inflow of flood into the reservoir to pass your dam, right? We talked about the purpose of your dams at the beginning, and these are not typically flood protection dams. These are for the purpose of irrigation. Sometimes they also provide some attenuation, but that is not the purpose of the dam. The purpose of the dam is to provide irrigation water. So when a flood comes, you just pass the dam. We've seen this in past extreme conditions and emergency conditions where dam owners feel, especially the pressure from downstream neighbors and things, that they should retain that water. But if you do that, you could potentially overtop your dam. So if your dam is performing as designed, it is not an emergency. You stay the course, you open your valves, and you pass that flood. So there's no obligation to raise your reservoir above safe operating conditions. So dam performance, a properly designed, construct and maintained dam can withstand, you know, larger floods and earthquakes. So do you know what yours is designed for? Again, those are things you want to know, and they should be listed in your operation maintenance surveillance plan. If you're looking and the river forecast system says you're going to get a 1 in 500 year flood and yours is designed for a 1 in 200, you might want to plan ahead and start drawing your reservoir down so you have additional capacity, because you know it's not designed for that. So again, there just says OMS manual. So sorry, I'm jumping through here. I'll just skip that one there. So continuing on that example, so let's imagine your flood intensifies. The event is starting to get bigger. Let's say you did check the river forecast system. It's saying, okay, there's going to be more rain. Dam is starting to overtop. Your spillway there is starting to erode. It's not doing well. The toe of your dam is getting eroded. Now what? What do you do? So, and I think the answers would be pretty clear, especially if you knew what's in your operation maintenance surveillance plan, because it'll say if it goes beyond these levels, it's probably an emergency. And then you'll have your dam emergency plan, and we're going to talk about how to activate your emergency plan, who the notification lists are, and so forth. So, Dwayne, you can take it from here.
Sure.
Yeah.
Just wanted to come back to this just very briefly. I mean, you know, if this is happening downstream, it's not because your dams failed. It's because the flood that's traveling through that watershed is an extreme event. And as long as your dam is performing as expected, you're fine. But the interesting thing is, if you felt obligated to try to help your downstream neighbors by holding back extra water, and by doing so, that causes your dam to overtop and breach, then you're kind of liable because you weren't operating it the way you should be operating it. And so it's really useful to kind of do the mental exercise to how would you operate your dam under those extreme event situations? And is that extreme event situation actually over and beyond the capacity of your spillway typically to pass that water? And then we do have that as an issue for some dams. The spillways they really are under designed as we get more and more information about the return periods for extreme climatic events. And climate change is also throwing another wrench into the whole thing, because we can expect to have perhaps more frequent flood events. But we want to make sure that you're operating as safely as possible and not doing something that actually creates a situation where the dam breaches. This dam did not breach, right, Aaron?
No, it didn't. That's about as bad as it got. Yeah.
But that's about as bad as it can get.
That's about as bad as it can get. Yeah.
Yeah. So switching over to a different topic, maintenance. Of course, all structures can fail if they're allowed to deteriorate, age and deteriorate. And we need to do some regular maintenance to correct defects before they get too extreme that they might lead to a breach of your dam. And one of the key things is to try to avoid what we call deficiency creep. You see things going a little bit wrong. Maybe some repairs are needed, but you just wait for the next year. You keep postponing it year after year, and the problem creeps up to be more and more severe. And we need to try to avoid that as best we can. Many older dams are probably under designed relative to current understandings of the hydrology of our watersheds, and then throw on that extra layer of climate extremes due to climate change, and they may need some upgrading to ensure they're safe. And so maintenance may not be upgrading. Upgrading is usually a bit more significant than maintenance, but it's a spectrum going from maintenance to an upgrade of your dam. Now, of course, to engage in maintenance, you need kind of a schedule and some financial resources to handle that. So you should kind of budget accordingly, set aside some money for routine maintenance, and then for those occasional and more major repairs, you need to know what dam components you have and what their maintenance requirements are, particularly mechanical components associated with your low-level outlet. Hopefully, in your OM&S manual, have a schedule of maintenance activities. It's kind of a reminder. It's no different than changing the oil in your vehicle, and then occasionally you got to do some transmission fluid and some other more major repairs. You can almost think of that same schedule needs to be kind of established for your dam and hopefully documented in an OM&S manual. And then keep a record of what you did and when you did it. So we're going to go through some examples that we're able to kind of pull out. So last week we talked about some of the deficiencies that can occur on a dam. So here we have rutting along the crest. And of course, water is pooling in that area, and it can soften and weaken the embankment, and maybe somewhere along this rut it pours over the embankment and causes localized gully and erosion. So it shouldn't look like this. It shouldn't have ruts on it. It should look like this after it was repaired. Same dam, repaired, perfect. Look at the rest of this structure, looking very nice too, because the trees that were kind of growing on the shoreline of the reservoir are also have been removed. So, both maintain the crest, maintain the vegetation. I always say that a dam should look like a dam. That kind of looks like a natural Mother Nature feature in the valley. Then your maintenance is deficient, because you got trees and things growing on it and gullies and animals living in it. A dam should look like a dam.
Dwayne, quick note on your last slide there. Another thing too is always make notes of this, because oftentimes you get a dam survey, you might even have localized settlement, but it's been regraded, and maybe one area you keep regrading it, and what you don't realize is you have differential settlement, and which I've seen. So always make a note and take a photo for the file, and it's really useful down the road. If you run into these types of situations, you can go through and find out what actually occurred.
Right, because placing this material on the crest could be hiding a more serious deficiency buried in the embankment.
Right.
Good point. These two photographs are taken from the same location. So this is your intake, and it's sitting right about there. And here's the small little, it's a small dam being overtopped everywhere because this structure is full of debris, and they're trying to clean it out. So, if you have intake structures, particularly before the spring freshet comes along, it's a good time to get out there and make sure they're clean. There's no debris that's been floated down or blown down the lake. If you have a log boom, making sure the log boom is functioning to keep the debris away from your intake. We talked about this last week in terms of just identifying deficiencies. So spillways, beavers like to build things in spillways, and so you're going to have to keep removing these block spillways. The spillway is often a very critical piece of infrastructure to bypass that flood that may come, whether it be a spring freshet flood or intense rainstorm later in the year. So keep those spillways clear of debris, both created by animals or maybe some slumps or small landslides that might be blocking off your spillway. This is an example. This is a before and after. This is just downstream of the dam. So there's a bit of an armored spillway here, but it's fairly full of debris, and the trees are growing up all around it. And this is after these trees. You can see the same boulders here. Some of the trees have been removed and pulled out of the way, so that there is less of a tendency for like a log jam to be formed there, and that whole spillway to be blocked, and then backing up into the reservoir and overtopping the reservoir. Vegetation, things like to grow, right? And so it's not so bad when this photograph was taken. What do we got here? Looks like probably some alder growing and some grasses and things. It's a bit thick. It makes it very hard for you to do your visual inspection of your embankment. So, this should be kind of mowed down, and you don't want your shrubs to get established and start to turn in from shrub to trees. And as I said, if your dam looks like a dam, nice and smooth and covered in appropriate vegetation, grasses, vegetation is great because it does provide erosion protection if you have those unusual occurrences where the thing starts to overtop. So you do want grass, but you don't want trees. And if you do have grass, it should be kept mowed so it's easy to visually look at your embankment for small depressions and deformations that might be signifying some sort of impending damage that's occurring within the embankment itself. And a couple more examples before and afters. And so the typical situation is that most people just seem to not get around to clearing off their trees until it gets really, really late. The dam safety officer is saying, do it. And then finally they're saying, you really have to do it, or we're going to do it for you and send you the bill for the maintenance. But it's much better to keep these things removed when they're small before the roots get really large and established in the embankment. Because if you chop off a big tree, those roots are now embedded through the embankment and they'll rot over time, and those can create preferential leakage pathways through your embankment. So if you have the really big ones, you almost have to take the tree out and the root ball and rebuild that part of your embankment. So it's much easier just to keep them removed when they're small, when they're shrub size only. Erosion protection, it could be riprap on the upstreams or here at the outlet of an outlet. Depending on where you are in the province, sometimes it's a little bit challenging to even find quality riprap. Riprap is another word for these rocks, big enough size rocks that you can kind of line your channels. So you want to keep things armored and make sure that there's no erosion eating back into your embankment. And here's an example on a small embankment where, first of all, we got some vegetation growing. It was removed, riprap was placed in there, and okay, there's that vegetation starting to pop back up. So it's pretty easy to get rid of the stuff when it's small like this. A little bit of shrubbery and vegetation is helpful because it kind of helps hold the riprap together and provides erosion protection, but we don't want large trees growing on our embankment. And if you were to look at, this is kind of a close-up view of the, well, ignore the the use of tires and car chassis as a substitute for riprap, kind of not recommended, and it looks like it's not working very well either. You want the appropriate kind of riprap that's continuous, and often we end up getting a little bit of a beach area established on your embankment. And so the riprap doesn't have to run all the way down to the bottom of your dam on the upstream side. We do have to have an idea what's the typical reservoir elevation fluctuation throughout the year, and protect that with the riprap. And so there's guidance as to the size of the riprap and the vertical extent relative to your full supply level. They're calling it still water flood pool. And if you have a particularly long dam, and if the dam is lined up facing the prevailing wind direction, your wave action might be a bit more aggressive, and the need for riprap might be higher. And we often, in some places we have some flexibility to orient our reservoir and our dam such that we can minimize the length of the reservoir in the prevailing wind direction, which again minimizes waves.
A note to that comment, Dwayne, is he had already mentioned a lot of your locations might not be that great to find riprap or source it anywhere. So stepping it, like Dwayne showed there, really does help. And you'll notice nature will do that on its own. But also other things you can do is use like a geofabric. You can start to get creative about what types of vegetation you want to start on their slopes, and also setting it back. A slope that's not so steep, at least in the area of the wave action, will help significantly. So,
and you may be able to get lucky and get some vegetation established in this area that kind of survives being underwater for a short period of time each year as well. So, vegetation is pretty good for minor erosion protection. I mean, this example is not much for vegetation helping out here. So, yeah, so those are probably the more common maintenance things that agricultural dam owners are probably dealing with. We didn't, I don't have any pictures here of dealing with burrows from muskrats or gophers or whatever wants to dig holes into your dams, but we talked about that a little bit on the inspection workshop last week. So I have another poll. There's the questions. What maintenance activity do you frequently perform? And you can, I think of these ones here, you can answer more than one of those. So I'll launch that poll. And then the other question is, do you record your maintenance activities in your OM&S manual? So just get a sense for what you do and what your colleagues do. So if you could answer those polls. So I'm seeing vegetation removal, debris removal pouring in. And we chose these kind of activities to be those that are probably fairly typical for you, and you can answer more than one of these questions. So I've got more than 50% of the people responding. That's probably good enough to get a sense for what people are doing. So I'll end the poll and share the results. So if you want to see how other people are doing, what they're doing compared to you, here's the answer. So we're seeing vegetation removal and debris removal from the spillway tied for the most frequently performed maintenance activity. Servicing the mechanical components is showing up pretty good, and erosion protection, riprap, or stuff like that. So, most dam owners, agricultural dam owners, will be doing these activities. And after you've done the activities, do you record, make a record of that? Some people record it always, and some people sometimes. And so there's always room to probably improve the documentation of those activities. And sometimes those documentations can be helpful, like years or decades later, that, it may be evidence that helps somebody else diagnose a problem that was slowly developing in your dam that you yourself didn't even know, but you're always filling in holes in one specific location. Well, we kind of need to know that, and that will guide the detailed inspection, particularly if you have to do a dam safety review. Good, I'll stop that. And is this mine or it's back to me? I think still, right? Yes, okay. So that was a little bit of on the maintenance. Just touched a little bit on monitoring. We kind of expect that most of your dams don't have a lot of instrumentation. Here's a little section from the regulations. An owner of a dam must do all of the following: install instrumentation necessary to essentially assure that the dam is performing well. So what they're really asking. Maintain and replace that instrumentation, collect readings, analyze and interpret that instrumentation. So this is how it's kind of specified in the regulations. And as I said earlier, visual observation and your eyeballs are part of that package of instrumentation. So just simply documenting the reservoir elevation against a staff gauge or against a collection of boulders that you may have placed along the upstream slope of your embankment. Hopefully, if you have some seepage issues, you're actually tracking and measuring the seepage. And so the regulations kind of want you to do that. And we'll just touch on a little bit of that here today as well. And some of this instrumentation and monitoring, you're doing it because you have an idea of what failure modes could occur. You have an idea how your dam can fail. So you're looking for evidence that it might be moving towards that failure. And you want to be able to know how well your dam is performing. So if you don't really kind of look at it and measure something, you may not know how well your dam is performing. You should have some idea of what is acceptable, like the acceptable amount of seepage coming through your dam or acceptable amount of water going through your spillway, and how to measure that. And some of those, the answers to some of those questions could be embedded in your OM&S manual. So what instrumentation, if any, do you have on your dam? Is the instrumentation itself adequate for your dam? So your DSO might be asking questions like that. Do you have enough instrumentation to monitor the performance of that structure? And do you measure it and record that instrumentation data frequently enough? And we'll look at the frequency here shortly. And how do you review and analyze that instrumentation data? So you don't want to simply take measurements and record them, stick them in a book, and never look back at the old measurements, measurements this year, last year, 2 years ago, to see if there's any change in that behavior. And all that stuff should be captured and recorded in some sort of document. And typically you'd want to place that document as a chapter or a section of your OM&S manual. So what type of instrumentation might you have? So I mentioned just moments ago, a staff gauge, some sort of pole with paintings or markings on that with the water level indicated on that. So you can see when you're standing on your dam, you can take a look and say, okay, the water level is at this value on this date, and make a note of that. You may on your gate stem, you may have some sort of ability to measure, was that thing fully open, half open, or what was the amount of opening on that valve or that gate. You may have a piezometer, which is a device simply to measure the water level, maybe measured at the foundation, but you read it up here someplace. This piezometer may be further down at the downstream toe. You may have some structure to capture seepage passing through your dam, and then to measure the amount of water going over it. And there's a thing called a V-notch weir, which really all you need is a ruler to measure the quantity of seepage that's passing through. You may have an outlet weir as well. So there are some quite simple low-tech instrumentation that might be appropriate for your dam. Of course, visual observation is always the best. Some of the disadvantages of some of these instrumentation is it's placed at a specific location in the embankment, and it may not be the appropriate location. Whereas when you do your visual inspections, you're looking at the whole thing. You're looking at the upstream, downstream, the crest, the abutments, the low-level outlets. You're looking at everything when you do your visual inspection. So it's a bit more comprehensive that way. It's interesting that if you go back to the regulatory requirements and link it to your dam classification, there was a table that's embedded in there, and it says monitoring instrumentation, and here's what it states. This is what the table states. But when you think about it, looking at some of these things that I just mentioned here once a year, I don't think that's going to be sufficient. I think you need to look at this far more frequently. So these are kind of a minimum required frequency of monitoring your instrumentation, and your OM&S manual should hopefully have a higher bar and have a rationale for recording things even more frequently than annually. Annual frequency is frequently not enough to ensure that you are operating your dam as a responsible dam owner and ensuring the safety of that structure. So I'm going to pass it back to Aaron.
All right, so seepage monitoring. So on that last slide there, Dwayne showed you a couple things. I'm just going to jump back real quickly to it. So this one here is just two little perforated pipes going into this drain, which is kind of a granular or sand material. And I'm going to talk about this example again real briefly because you can see I have my thinking face on. We had quite a bit more flow coming out of this one, and you would call that the left drain. So again, another reason why you want to be consistent. You always want to reference things looking in the direction of water. So the left drain there was actually getting quite a bit more water. But anyways, this is typically what we might do. We just a bucket and timer, real simple tech, and fabulous information. I'll talk about that one a little more in just a little bit. So here's some more seepage monitoring. Maybe you don't have two direct, perforated pipes or drain pipes where you can bucket time. It might go into a little catchment area here where you've got a V-notch weir. Could be a 90-degree or 60-degree sharp edge weir, whatever it is. The main thing you're looking for is change. We're not going to go into too much detail about the actual analysis components, but really you just want to have a way to be able to measure and the performance of your dam. So whatever is most practical for your dam, you want to put it in. And again, instrumentation is a bit of a double-edged sword. If you don't need this much, that many pieces, don't put them in. Otherwise, you probably just won't end up monitoring them if they're not useful information to you. And then the regulator is going to go, why aren't you monitoring your instrumentation? So you want to put in only really the amount of instrumentation that is valuable for you to be able to understand how to operate your dam and how to ensure that it's performing as designed. So here's an upstream reservoir staff gauge. Instead of having a staff gauge, say in a valve chamber or something, you may just have markers on your upstream valve stem. So something like that, whatever works for you is going to make it more practical. So here's one of those piezometers or standpipes. Like I mentioned before, be consistent. In this particular case, the owner always measured from the top of the well cover. It was easy because you can slap a ruler on it and it's consistent, and especially because in some cases they'd have 2 or 3 piezometers at different depths side by side in the same well top or in the same hole. So that way, if one's a little taller than the other, they always have the correct elevation for offset from top of a reference point. So whatever you do, be consistent. And so that's an example of how you just got an electronic water tape that beeps when it hits the water. So here's some piezometer information. This is from a real dam. I won't say which one, but you can tell they have quite a few, they actually had quite a number of piezometers, but here we're only looking at one piezometer, and we're looking at the reservoir elevation. So the different colors are different years. So each year, for example, it might be, this year, the blue in the blue is 2014. The piezometer level kind of goes up and drops off, and it kind of agrees with the reservoir. As the reservoir goes up, after some time, the water level, it could be even weeks, depending on your material, that your piezometer starts to respond and come up, reservoir comes down, then the material in your dam starts to drop off. So the reason why we monitor this information is we don't want to see changing conditions. So here's an example, 2019, you have your reservoir, again, these are staff gauge readings, so just reservoir elevation. You're plotting it along, the reservoir comes up in the spring, you start to use and draw down that reservoir, you kind of end your year off where it's just drawing down a little bit into December. And then that same year, oh my God, it's kind of doing the same thing it always does. And what we'd expect this next point to do is maybe be down here somewhere, but for some reason it's gone up. So that's something you're going to want to ask yourself, how is the piezometer coming up like that? Is there an issue? Just like if there's a tow drain that you're timing with a bucket and timer, you say, well, it takes 25 seconds or whatever to fill this bucket, and then all of a sudden it takes 3 seconds. Well, there's been a huge change in flow. So what's happening there? It definitely warrants further investigation. Most of the time, this ends up just being a measurement error. But when it's not, you're really glad that you had that instrumentation there. And I've seen several cases where we've potentially saved a dam.
And Aaron, on that example, yep. You can see the frequency of measurement is roughly monthly, mm-hmm. except in the summer months when the reservoir is high, and that could be more critical in terms of the failure modes. Then they're measuring that piezometer more frequently. Mm-hmm. And so certainly one measurement a year is not going to be very useful with these type of piezometers. And so those guidelines that are in that table that was shown earlier of doing it once a year is not appropriate if you're trying to look for these change in trends.
And another reason why you want to have your reservoir elevation always recorded, if you're measuring whether it be seepage flow rates or piezometer elevations, makes a lot more sense to have the reservoir, because if you read a high point, well, maybe the reservoir is high and it makes sense. So only put in the instrumentation that makes sense to monitor, and then know what to look for. So you have to actually start to work with your data and know what is normal to know what's not normal. Otherwise, there's no reason to do it. And there's every reason to make sure your dam is performing. So you want just the information you need. So Dwayne, I think you've got a poll here coming.
Yes. So we're just going to have a quick poll about what you guys might be doing for. Oops, I'll get back up. And there's the questions, and I'll quickly find that poll, hopefully quickly. Monitoring, launch the poll. So in terms of the people participating today, do you measure and record the reservoir water level? Do you measure and record seepage anywhere through your dam? So let's get a sense for what people are doing out there in practice. So I got 16 people have responded so far. I'll just give it another few seconds. I'm kind of coming up to the 50%. Yep, I got more than half of you responded. That might be enough to get a sense for what people are doing in practice. I'll end the poll and share it. Okay, so do you measure and record the reservoir water level? Yes. I suppose the question could have been more nuanced. Do you measure and record the water level almost every time you do an inspection or not? Is it once a year? Or is it, hopefully it's, because it's can often be a very fast thing to record when you're out there. And then do you measure and record seepage? And so the response to this next question doesn't surprise me. In many cases, the amount of seepage going through our embankments may be very small, and there's nothing really to measure or monitor. In other cases, you might have seepage, and that's a smaller percentage of the dam owners. Good. So I'll stop showing up.
And I wouldn't be surprised if a lot of you that said no may actually still be looking for wetted areas or aquatic vegetation. And if you note the fact that there's wetted areas and aquatic vegetation, you are looking at the difference of that from one year to the next. So there is some seepage monitoring even in visual inspection. And sometimes that's adequate and all you may want for your particular dam or location on your dam.
Yeah, if suddenly cattails were growing in a location where they never grew before, that's a warning.
It's a problem. Could be a problem.
Could be a problem.
Okay, let me see here. So equipment testing. So I'll try to keep a little bit faster pace so we stay on time here. So again, one more thing. It's right in the regulation. Do it annually. Should you do it more often? Maybe. If so, get it in your OMS and plan it. Just like your testing, same for your instrumentation. You want to try to set up your dam so things are practical. If they're impractical, you probably won't do them. So you might want to modify your valve or your wheel or something like that so it's easier to operate. Whenever you can, make it easy. Whether you make your records on your phone or what have you. So we're going to look at equipment testing a little. Do you know all the equipment on your dam? So you kind of have to have an archive or a list or something in your OMS that lists all the pieces that you've got. Are they automated? Are they run by some sort of SCADA system? Probably not for many of you, but you want to know what those pieces are, especially if you're delegating it to other operators. Maybe you have another licensed user who fills in for you as well and does a little bit of it. So it keeps you both on the same page, keeps you both recording the information in the same place. Do you know the service life of your equipment? Is it near the end of the service life? Again, just like a vehicle, you want to have all that information. So here's a typical slide gate. Actually that's a screenshot of a list we put together. I think it's in the link of that big dam safety management binder example I sent earlier today. But you're going to want to, again, make it as simple as possible. Crop just the little piece that's useful. Put that, maybe attach it on the bottom of your surveillance or inspection form. So when you do your annual testing of your equipment, you can do it right there quickly, right on your surveillance manual or whatever it is. And again, we covered the surveillance and inspection documents on the last webinar, so we won't go into that more here. So here's another example of a slide gate test. So during a formal annual inspection, a valve test was requested. So, and I say requested, and if there's any consultants or anyone else on here, or certainly to all you operators, if you have an engineer or someone come do this for you and they ask you to open a valve, remember that it's you opening the valve. You should already know what are my safe limits, all those things. And if you're a consultant or or an engineer, you want to make sure you don't demand those things if you don't know anything about that system. So anyways, in this particular case, valve test was requested. We wanted to do it during an annual inspection. Operator conducted the test. We checked beforehand. They didn't know the maximum safe discharge for that valve. So since the maximum was not known, what we decided to do is slowly, incrementally open it up and look at the whole system. So what can we learn about the system? And so it was a valuable process. So equipment checklist in this case was used, and we went through for that particular system. So I'm going to continue this. Prior to actuating, much of the checklist was already done. So just informally started going through the checklist. In this particular case, it's a chamber on the crest. It's operated with a gate wheel. It's all enclosed. the stem goes along the upstream face of the dam, and it's all within a oil reservoir. You can see some of the oil. We even see where it leaks. It's like a vegetable oil was leaking into the chamber. You could see it in there, so we just knew it needed to be topped up, and there'd be a small leak in the system. Other than that, everything worked. It was locked appropriately. Everything was generally quite new. So before actually actuating the valve, excuse me, we looked at the downstream conditions. So here's the low level out, or the low level outlet outfall, and then this has been a riprap channel. So this is a photo taken from the same location, looking downstream, so looking out of the page this way. The release channel goes this way. You can see actually the top of a forestry service road. You know, we noticed little things like vegetation. The slopes are fairly steep. Just a couple things that were noted in the inspection prior to the test. So we started opening the test, or opening the valve. Test was continued incrementally, and we basically just continued to monitor what it looked like in 10% increments. So by the time we got to 50%, we did terminate the test. So here's a picture of it before the test, just like you had seen in the previous slide. This is probably close to the 50% when this photo was taken, so you can see the red line. Probably increase of about 2 feet, I'd say, maybe not quite that, in this channel. That was enough to back up this outlet, or I should say CMP pipe crossing the forestry service road at the end of that channel. And it was certainly stressing the system, so we immediately terminated the test. So you can see how high the water was here. So if I go back, you can see it was swirling at the that pipe, and then so the water was probably up to about here, and you can see a little bit of suction. The water kind of soaks up into the material. So it might have been running like that for a period of 5, 7 minutes, 10 minutes, but it was enough time to saturate this bank. And then when we shut the valve, even though it was shut relatively slowly, this pipe drained the material out quicker than this bank probably would have liked, and some of this slumped down. Again, a function of steep banks here. You could see some of the sands and stuff got redistributed in the bottom of that channel. Going to the next slide, we showed a line there that we probably went up to about 2 feet, somewhere in this range on the outlet. You can see some of the riprap got displaced as the water kind of came out and hammered this bank. It moved it over to the side. You can see it's kind of hard to see with the reflection. Best photo I could get. It kind of gives you an idea. Maybe we should never open this valve more than 25%. Even in an emergency condition, you open it 50%, you're probably going to fail the slopes of your outlet system, causing some slumping, and then you get 0% because you can't release anything. So it was really important to know. Now, I wouldn't say the system's undersized. It's just the valve is bigger and the outlet is bigger than it needs to be. And now we know what the limits of the downstream system are. So we will note that in our OMS system not to open it beyond that safe operating limit. So yeah, this is basically summarizing what I just said. New maximum safe discharge setting. We also, even if you're going at 25%, you definitely in this case want to knock that flow back nice and slow. Knock it off another 5%. Go do some of your surveillance checks, maybe clear the spillway, come back, knock it another 5%, and then set it to where you want to go. So these are all things you definitely want to consider. So a perfect example of how a simple surveillance, or I should say a simple gate test, all of a sudden brings a lot more information to your OMS and makes your whole dam safety management plan a lot more robust, just by simply taking notes and adjusting your planning. So, repairs. I got a few more. Dwayne, I'll try to keep the pace up here.
Yep.
So Dwayne mentioned this: adequate financial resources to operate a dam. It is an asset. It's only going to be a good asset if you continue to reinvest in it. Do it early, and it'll be you'll save yourself a lot of headache and potential big capital cost upgrades later. You got to meet minimum best practices. They have changed, climate change. There's other things that have made those the bar increase. So sometimes we do have to just chew off the we got to bite the bullet, so to speak, and get it up to snuff. So there's a difference between a repair and an upgrade. I'm not going to go into too many details, but best thing to do is call your regulator. If you've got questions about how do I, what's the best way to navigate this? Is this something I need to do a full application for? Whatever type of work you're doing, it's best to talk to them first and then discuss what the scope of work is and then proceed. I would recommend that no matter what, but we'll give you a little bit of sense of what may be required. So, quite often if you have to divert water around, maybe you have to maintain environmental flow needs, those types of things are definitely going to require some sort of a formal application through the dam safety branch. So repair may be considered an alteration or an improvement. Again, I just said contact your regulator. So an alteration or improvement to or replace. So basically all or part of your dam. So must be authorized. So if you're repairing a valve or something like that, you may not require authorization. But if you're taking something off and actually making an alteration, maybe changing the size or doing something of that nature, I would definitely assume that you would plan for a full authorization and application. The extent of how much information you're going to need is really going to depend on that scope. And so the question is, does it fall into routine maintenance, right? Or doesn't it? So if it's in routine maintenance, you can go ahead and do it. If you're removing vegetation on your dam, it's probably just routine maintenance. So there's a bit of a gray area there. And again, best to talk to your regulator. So question, does installation of a new upstream valve and concrete chamber require authorization? So here's a picture of some work that was recently done on a dam here in BC. So you can see some big bags in the creek, or I should say bladders, quite a bit of water work. So this is obviously yes. Generally, any work that goes beyond routine maintenance requires authorization. So here's a repair example. This one did need authorization as well. We're working in the water. It goes beyond routine maintenance. Clearly, the outlet structure is in rough shape. If your outlet structure looks like this, it's probably time to just spend the money and get it fixed up. Even if you can't see how it could potentially cause a safety problem, it just takes one little thing. And so here's an example of the drawings that were put together. DSO was notified of the intent to repair. There's some discussion. Environmental flow needs did need to be maintained, so there's a bit of a diversion plan there. And so just simple drawing letter, and it was approved, and the as-built, or I should say record drawings, were put together afterward, and it was filed to their records and to the dam safety office. So here's a picture of before and after. And there again, you have 30 days to submit your completion report, which can be very simple. So again, update your records. And there's some requirements in there as to the timing and what type of information needs to be included. So again, just refer to your regulator and your regulation.
Good, thanks, Aaron. I just wanted to come back and touch on one other thing in this under section 12. So if you've got some sort of impending failure that could result in a release of your reservoir or breach, you have some sort of hazardous conditions, and you have an idea of how you can conduct repairs to protect your dam, do so.
Yes.
Your primary objective is dam is dam safety, which links to the safety of everybody, the environment and people downstream. So you don't need to worry about getting approval if you have to do something very quickly to save your dam.
Yeah, and that would be an emergency condition. And
Yes.
I would also state, we are going to talk about this at more length in the next webinar as to, if it's maybe a level 1 emergency and it's slowly developing and you're already on the phone with your regulator, they may be able to issue you an order, right? So you can do work that meets the Water Sustainability Act requirements under an order. So you wouldn't have to put all those things. I joke and always say never waste an emergency, because sometimes you can save yourself a lot of paperwork. You should never plan for that, but in an emergency, oftentimes you can work with your regulator, and a level 1 emergency, you want to be on the phone with them, and maybe you can intervene under an order, and that would be the best way to go. But in other cases, if it's going to breach, I mean, follow that damn emergency plan. You've got to get your notifications list, and you got to act. So we're going to talk a lot about that in the next webinar.
So we're coming close to the end of this one, and we just have a couple of slides sort of stressing the importance of keeping organized and keeping records of your maintenance and your repairs. And the regulatory requirements requires you to do more than just do what's required. You also must record it. It's built into the requirements. So keeping records is a key component of a thing called a dam safety management system. And you know, we're just here to say, please try to do your best to record all the activities that you conduct on your dam in terms of surveillance, maintenance, and repairs. There are additional resources to help you with the OM&S manual, and we generated some of these things a few years ago as part of some workshops we did with the Caribou Cattlemen's Association. And so you can find that at these kind of websites. So if you go there, you can find them, or certainly you can talk to Aaron. He's got all these documents that can be shared with you. And of course, the dam safety section in BC has a lot of these same resources available. So we talked about that last week. Make sure you're familiar with that website. It's pretty fast to find. Just type in Dam Safety BC, and I bet you find it really fast in the Google search. And then once you're in there, you can find various resources. And of course, use your dam safety officer as a resource too. Feel free to give them a phone call. You can find their contact information on the website.
Dwayne, a quick note to the last, yeah, you can be on that slide. I just sent a URL to everyone. The second last one. The last one goes right to that page. The second last one, under this project, we maintain an internal document of all the available documents from BC that are related to dams. So what we've done in that second last link on the chat, if you click that, it'll upload the PDF document that lists every single one of those documents. They're all hot linked. So as long as you're connected to the web, it'll bring you right to them. And it has a quick blurb about what's in it, just in simple terms, and a quick blurb about how it's useful as a dam owner. Again, these are our opinions, because if we say something's maybe not so useful for a dam owner, those are our opinions, but it really does help. And I know it's been a real valuable resource for myself, just trying to find these things and even just navigate my own way around. So I encourage you to download that link. It's very helpful navigating where all these things are.
So we have just one more thing to do, if we could indulge you, and to just answer some more questions very quickly, and then we'll kind of open the chat and answer any questions that you might have. So I'll start the last poll, if we could just get some feedback from you. And of course, this 3 p.m. Pacific Standard Time, next Saturday, we will have our third and final webinar dealing with emergency planning and response. And so I've only got one slide left, but take advantage of us and the other participants, but to fire some questions in the chat, and we can kind of Aaron or I can read out the questions and hopefully answer some of those questions. So I'm going to end the poll now. I've got enough feedback. Thank you. I'll share the results, but only very quickly. So, oh, geez. Thank you. We're about right in terms of our timing this week. And it sounds like a majority of you learned something, which is also nice to know. And hey, I like those guys that already have and use a good OMNS manual. Wonderful. But it looks like we have a few others that need to develop their manual or to update it. And so, there are resources out there to help you do that.